Hello, my name is Nitin. I am excited to share that we have just received a beta version of the brand new DAISY 8 module Sense version 1.0. We have developed this module in response to increasing demands from regulators and manufacturers for comprehensive and easy testing of proximity sensors used to mitigate user exposure. The solution is also compatible with the latest IEC Draft Technical Report 63424 titled Validation of Dynamic Power Control and Exposure Time Averaging Algorithms, as well as with other IEC, FCC, and ISED specific absorption rate SAR standards. Module Sense is based on the DAISY 8 3D hardware that combines phone positioning with the CSAR 3D vector array system. It is flexible, which means it does not only enable testing according to the latest standards, but also any user specified test sequence consisting of separation distance and dwell time. Today in this video, I will evaluate the new module Sense and measure the proximity sensor response for two devices. The first one is enabled with a conventional proximity sensor, which immediately reduces the output power at a predefined distance from the phantom. The second one has a time averaging proximity sensor, and we will evaluate it according to the static and dynamic test sequences defined in the IEC Technical Report 63424. I place the first device in the pickup station and then move to the computer to set up the project. For the first device, the project consists of measurements at LTE band 1 from 30 millimeters to touch position in steps of 1 millimeter with dwell time of 5 seconds at each step, and proceed to measure. After the call is connected, the robot proceeds to pick up the device and moves it to the phantom. The measurements proceed according to the test sequence, while the CSAR 3D continuously measures the instantaneous as well as the time averaged SAR values that are updated into the graphical user interface here. I accelerate the video. Measurements are now finished, and as the graph shows, the proximity sensor has triggered a power step at 3 mm from the phantom, as each step in the graph corresponds to 1 mm separation distance. This is the dprox distance defined in the standard. Measurements can be made in all test positions and according to any custom defined test sequence. Let us now evaluate the second device. I have prepared the following project. The project includes the static and dynamic test sequences defined in the IEC draft. We first test the static test sequence. I run the sequence. It consists of measurements at greater than d proximity, followed by those less than d proximity, and then back. I accelerate the video. Here we observe that the TAPS algorithm is functioning correctly. Unlike a non-time averaged proximity sensor, there is no immediate power reduction when the sensor detects the proximity of the phantom. The high power section highlighted in the red circle shows this clearly. The pattern repeats with the algorithm's averaging time, which is 360 seconds in this case. Next, I select the dynamic sequence and run it. This sequence consists of several distance steps which are greater than or less than the proximity with varied dwell times. I accelerate the video. The measurements are now finished, and we see that the TAPS algorithm maintains the time average SAR below the target SAR level at all times. All measurements can be visualized in the graphic user interface and can also be exported to Excel for other applications. The Excel export has timestamp and distance along with instantaneous and time average 1 gram and 10 gram peak special SAR values. Module Sense allows complete control over the test sequence definition with possibility to define custom sequences. I find the DAISY 8 Module Sense version 1.0 beta to be extremely easy to use. The simple graphic user interface hides enormous amounts of robot control, measurement, and computation complexity. The uncompromising precision and accuracy of the CSAR 3D vector array technology delivers outstanding performance with measurements in as little as 300 to 400 milliseconds. This beta version already meets all regulatory testing requirements for routine evaluation of the complex algorithms in time averaging proximity sensor or TAPS technology, while also offering the flexibility to run custom user-specific tests. I am also very curious to see the next release, which, according to Spiag, will also include testing for motion sensors. Thanks for watching this video.